Good morning. This is your stat sensei, Mr. Spensei, and this is the test review for the normal, the inverse normal, and distribution of means or central limit theorem. So, the population mean and standard deviation for the GPA. You know what? I should back up real quickly. If it's written in blue ink, it needs to be on your test. So, everything in blue ink needs to be on your test. If it's in red ink, it's suggested but not required. So the population mean, the standard deviation for the GPA of all non-traditional students is the mean of 350 and a standard deviation of 5. So I'm going to go ahead and write that down. Mean is 350. Standard deviation is 5 or zero point 0.5. This is 3.5 and this is 0.5. And this has a sample size of 100. Please look out for that 3.5 and that 0.5. Draw a graph illustrating the empirical rule for the distribution for the GPA of all non-traditional students. You must show 3 standard deviations above and below the mean, clearly label the z-scores and the actual values. You must show the standard deviation. All right, please remember when we're illustrating the z-score, the empirical rule, we need to also give the percentages associated with it. So z-scores, and I'm going to note this off to the side once again. If it's in red, not required. So the z-score has a mean equal to 0 and a standard deviation equal to 1. So we're going to start off with that first. So our z-score is 0, 1, 2, 3, all the way to positive infinity. And then -1, -2, -3 to negative infinity. And then put a Z out here just to let us know that those are Z scores. Also, all that we need the mean labeled because that's the mean of our Z scores. And this is 68%, plus or minus 1 standard deviation. Plus or minus 2, which I'm sure we know very well by now, is 95%. And then plus or minus 3 is 99.7%. All right, so there we go. We've done the z-scores, but it also asked for actual values. Well, the mean of our actual values was 3.5. And, oops, I need to put this in blue because everything we say in blue has to be on your test. And I'm going to go ahead and write it over here. Mean of 3.5, standard deviation is 0.5. So once again, we're supposed to label our standard deviations, which means there's a 0.5 difference here, a 0.5 here, a 0.5 here. They're all shown in blue. You have to do these. 0.5 here, 0.5 here, and 0.5 here. Okay, this is going to be 4.0. Adding the other 0.5 is 4.5. Adding to this is 5. This taking away 0.5, we're down to 3. Take another way, another 0.5, we're down to 2.5. Take away another half, and we're now down to 2. Now, please remember, you can only use the empirical rule for the normal distribution, but you can use it for any normal distribution. It applies to any. It applied to the z-scores, which is a standard normal, and it also applied for our actual value because it was following a normal distribution. Okay. The next thing, number 2. And by the way, this should have said up here um, that it's normal, and it will on your paper, right? This should say that it follows a normal distribution, and I'm just going to let you know that it does. Otherwise, we couldn't have done any of this work. So the next thing, 76% of the students will have a GPA that fall within what interval about the mean? The very fact that they gave you a percent lets me know that we're working with a inverse norm. All right. And it's centered about the mean. So here's what that's going to look like. First off, I need to draw a picture. And in this case, we have a mean of 3.5 and a standard deviation of 0.5. So I'm going to go ahead and put the 3.5 here because that's my mean. And we're going to be looking for a lower bound and an upper bound. And this center section right here should be 0.76. Please remember, percentages are always divided by 100. So 76 divided by 100 gives me that 0.76. I'm going to go to my calculator and write my calculator commands, which in this case is inverse norm. And when I go to inverse norm, it says, hey, we want the area. So they're looking for the percentage. They're looking for that 0.76. They're also looking for the mean, which was 3.5. And they're also looking for the standard deviation, which is 0.5. We need to label those. This will be PMS. Our probability, our mean, and our standard deviation. And in this case, we need to write the word center because that's what we're going to use on a calculator. So, second vars, inverse norm, 0.76, mean of 3.5, standard deviation of 0.5. Make sure center is highlighted. Press enter. And we get a lower bound of 2.1925. And we get an upper bound of 4.0874. Put that in parentheses and label that lower and upper because those were the values that we were looking for, that lower bound and that upper bound value. All right. Number 3, suppose 100 students are randomly selected from the population. Give the mean of the sampling distribution of X bar. Well, this is an easy one because the mean is the mean is the mean. So the mean of the population equals the mean of X bar. And the mean of the population, we said, was 3.5. So the mean of X bar is 3.5. Very easy. The next one is give the standard deviation of the sampling distribution. Now, please remember, they told us the mean of the population was 3.5, and they told us the standard deviation of the population was 0.5, and they also gave us the sample size, in this case, of 100. So, need to write all this stuff down if it's in blue. The standard deviation of X bar equals the standard deviation of the population divided by the square root of n, which in this case is 0.5 divided by the square root of 100. Everything else, if it's in red, you don't have to show it. So this is 0.5. Square root of 100 is 10. So then when I come to my calculator, I have 0.5 divided by 10, and I end up with 0.05. So the standard deviation of X bar equals 0.05. All right. So moving on to number 4. What is the probability that A, okay, when we see the word A, they're telling us N is 1. If that's the case, then this is going to be a norm CDF. Selected student has a GPA between 3.7 and 3.9. So here's what we need to see on your test. I need to see your drawing. Well, we know the mean. The mean is here at 3.5. And we're looking for 3.7 to 3.9. Now, where you put the 3.7 and 3.9, if you put them up top or down below, it doesn't matter. So that's my shaded area, 3.5 to 3.7. My probability statement is the probability that 3.5 is less than X is less than 3.7. If it's in red, I don't have to see it. But what I do have to see is because this is a norm CDF, you're going to have to show me that. So norm CDF. And lower bound is 3.7. Upper bound, 3.9. Mean, 3.5. Standard deviation, they told us up above was 0.5. We're going to label that. That's our LUMO. Lower, upper, mean. And no, it's not an O, but sounds good as an O. So now we're going to drop this in the calculator. Stat, second vars, normal, CDF, lower bound, 3.7, upper bound, 3.9, mean, we had a 3.5, standard deviation, 0.5. And we end up getting a probability of 0.1327. So the probability that a randomly selected student has a GPA between 3.7 and 3.9 is, and always box your answer, 0.1372. Oh, 1327. All right, number 5. What is the probability that a 100 student sample has a mean GPA less than 3.4? So this is a sample mean. Well, that's important. This tells me we're looking for an X bar, so we're going to be using a Z-test. All right, so here's what we need to see. We need to see that picture again. Well, what was our mean of our population? I'm just going to write it over here. The mean of our population was 3.5. Our standard deviation is 0.5. And here they're telling us we have a sample size 100. We need to keep that in mind as we work through this problem. So looking at number 5, running a little bit out of room. And we have a mean less than 3.41. So our picture, we're centered at 3.5. That's our mean. We want to know the likelihood that we have an X bar of 3.41 or less. So that's our shaded area, 3.14 or less. Our probability statement would be the probability that X bar is less than 3.41. If it's in red, you don't have to show it. But as we said before, this was a Z-test. So we need to write that down. Z-test. Stat, test, Z-test. Mean. Well, we said our mean was 3.5. We said our standard deviation was 0.5. We said our X bar was 3.41. We said our N was 100. And we have a less than. We need to make sure that less than is shaded because that's what it asked for. So what do I need to see? I need to see the mean is 3.5. The standard deviation is 0.5. The X bar is 3.41. The N is 100. And then I need to see that that you're using the less than symbol. All right. So the formula, I'm going to put in red. It's not required. Z equals X bar minus mu standard deviation divided by the square root of n. So what we're looking for is the probability that Z is less than 3.4 minus 3.5 divided by 0.5 divided by the square root of 100. So let's go ahead and run this thing. I already have the information in the calculator. There's the 3.5, the 0.5, the 3.41, the 100, and the less than. And we end up getting the probability that z is less than negative 1.8. And we need our answer. And of course, our answer is going to have to be in blue and in box. So 0.0359. Please remember, anything in blue has to be written on your test. Everything else is optional. Okay. Number 6 and 7. What is the probability that the average GPA for a sample of 23 students is greater than 3.7? So we're asking for average. So that means we're asking for an X bar. And we have a sample size of 23. Oops. So let's go back to what we know. We know our mean is 3.5. We know our standard deviation is 0.5. And we know that our sample size is, in this case, 23. And I could have done all that in red. And then the probability is that our X bar is greater than 3.7. So let's not forget that as we go about our problem. So we know we have a mean of 3.5, so we need to draw that picture. And we want to know the probability that they have a 3.7 or more. So there's my X bar, and we're shading up because it said greater than. And I know that this is a Z test because they're asking for an X bar and N is not 1. So this is a Z test. So I need to write that down on my paper. So Z test. Well, the calculator is going to ask me for my mean, which is 3.5. It's going to ask me for my standard deviation, which is 0.5. It's going to ask me for my X bar. And we're looking for the probability that X bar, the average, because remember X bar means average, is greater than 3.7. So our X bar equals 3.7. N is 23. And we're looking for a greater than symbol. So my formula, not required, Z equals X bar minus mu, standard deviation divided by square root of N. So plugging in, I have the probability that Z is greater than 3.7 minus 3.5 divided by 0.5 divided by the square root of 23. Once again, if it's in red, not required. In blue, I expect to see it. So let's go to our test. Let's go run this thing on a calculator. Stat, test, Z test. 3.5, 0.5. 3.7 is our X bar. Our sample size is 23, and we're shading greater than. So the probability that it's greater than 1.918, probability that Z is greater than 1.9183 equals what we care about, the 0.0275. And boxing our answer. Once again, anything in red not required, everything in blue is. Number 7, what are the z-scores associated with the middle 89% of the data? Well, one thing to keep in mind is all z-scores have a mean equal to 0 and a standard deviation equal to 1. And since it's giving me a percent, I know I'm working with an inverse norm. So let's go ahead and draw our picture of what this is going to look like. So here's my mean of 0. This is going to be a lower bound and upper bound. I'm going to be looking for this middle section right here. And I need this to be 0.89. So this area right here, or probability, is 0.89. Please remember all percents are divided by 100. That's where that 0.89 came from, 89 divided by 100. So I'm going to be looking for a lower z-score and an upper z-score. As we said, this was going to be an inverse norm. The area is the first thing it'll ask for, so 89. All z-scores have a mean of 0 and a standard deviation of 1. And this, I need my where it's located, and this is center. And in this case, this is my P, M, S, my probability or percent, my mean, my standard deviation. Let's go ahead and run this thing. Stat, second vars, inverse norm, area 0.89, mean is 0, standard deviation 1. We are already centered. We're good to go. And we end up getting negative 1.598 to positive 1.598. And that's my lower and upper z-score. All right, continuing on. Well, I hope to continue on. There we go. Excuse me there for a moment. So a survey is planned to determine the mean monthly lodging cost of employees of a large company. The population cost is 3,350 with a standard deviation of 773. All right. Once again, they should have told us that the underlying distribution is normal. So I'm telling you right now, distribution is normal. So suppose a simple sample, so we have a mean of 3,350. If it's in red, you don't have to write it. If in blue, you do. So mean equals 3,350. Standard deviation is 773. And we have a sample size of 143. Well, the first question is give the mean lodging cost of the sampling distribution of the means. Well, we're lucky. That's the easy one. The mean is the mean is the mean. They've already told us the mean is 3,350. So the mean equals the mean of X bar, which equals 3,350. And this is in dollars. The standard deviation of the means, of the sampling means. So in this case, they're not asking for this. They're asking for the X bar. And the standard deviation of X bar is the standard deviation of the population divided by the square root of n, which in this case is 773 divided by the square root of 143. Seven 73 divided by 143. I'm going to just raise that 143 to the half power. And I get 64.64. So the standard deviation of X bar is 64.64. And I'm going to put a dollar sign. All right. And I'm going to go ahead and truncate it at 4 places just to be consistent. Number 9, what is a z-score associated with the bottom 6% of all lodging costs? Well, we have a couple things we have to consider here. 6%, I see 6%, and that says, oh, they give me a percent, I'm thinking it's inverse norm. The next thing is they say z-score. Well, all z-scores have a mean equal to 0 and a standard deviation equal to 1. So I need to keep that in mind when I'm drawing my picture. So my picture is going to look like, oh, and the next thing I need to do is anytime they give me an inverse norm and it's like a upper or lower or something like this, I always draw an X. And this says the bottom part. So this means this part's going to be 0.06. It's below X. All right, because it said the bottom. Please remember all percents are divided by 100. So with that said, mean is 0. And this area right here is 0.06. And we are not looking for an X value. We're looking for a Z-score. So that should be a Z, and this should be a little mean. So then we're going to go ahead and write inverse norm. And we have the first thing it's going to ask for is our area, which is 0.06. Then it's going to ask for our mean, which is 0. Then it's going to ask for our standard deviation is 1. And we shaded from the left. So this is my PMS. My percent, my mean, my standard deviation. Second vars, inverse norm, 0.06, mean is 0, standard deviation 1. There's my left. And we end up getting a probability of negative 1.5, not probability, this is a z-score, a z equal to negative 1.554. Once again, if it's in blue, you need it. Z equals negative 1.5547 because truncating at 4 places. All right, number 10. What is the probability that a sample of 75 employees has a mean lodging cost of less than $3,200? Well, our original mean was 3,350 with a standard deviation of 773. Oh, and here we have a sample size of 75. Awesome. So, drawing our picture. First off, we have a mean sitting right here at 3,350. And 3,200 is somewhere below that. So this is 3,200. Now, because this says mean, that means I'm looking for an X bar. So this should be labeled as a X bar. And we're looking for a less than. So that's what it should look like. Also, because we have an N not that's not equal to 1, this is going to be a Z-test. And we know our mean is 3,350. Please remember, if it's written in blue, I need to see it. Standard deviation, in this case, is 773. N happens to be 75. Excuse me. Need to do X bar first. X bar, because that's what's going to be on the calculator. X bar in this case is 3,200. Our probability statement, which is not required, probability that X bar is less than 3,200. Looks like that. Now we have N equals 75, and we have a less than symbol. Our formula is Z equals X bar minus mu standard deviation divided by square root of n. So we're looking for the probability that Z is less than 3,200 minus 3,350, that's my mean, divided by 773 divided by sample size, square root of 75. Once again, if it's in red, not required, blue, required. Stat, test, z-test, mean, 3,350, oops, mean, 3,350, standard deviation, 773, X bar, 3,200, standard sample size, 75. We have less than highlighted. So the probability that Z is less than negative 1.68 equals 0.0464. Please remember, if it's in blue, I need to see it. All right, the next one. What's the probability that a family's lodging cost exceeds 4,350? Be careful. A means 1. So this is telling my sample size is 1. This tells me I'm using a norm CDF. So we can see from previously that our mean was 3,350. And I'm looking for an X, not an X bar, because it's a. If N is 1, it's just an X of 4,350. All right, this will be a norm CDF. It's going to ask for my lower bound. My lower part of my shading is 4,350. The upper bound's positive infinity. The mean is 3,350. Standard deviation 773. That's my lower, my upper, my mean, my standard deviation. We call that the LUMO. Stat test, second VARS, normal CDF, lower bound 4,350, upper bound 9 raised to the 99th, mean 3,350, standard deviation 773, and we end up getting 0.0978. All right, number 12. 9% of all lodging costs will be below what? Once again, if they give you a percent, probably an inverse norm. Also, please remember, divide all percents by 100. So in this case, I'm looking at number 12. I'm going to sit there and go, okay, I'm draw my X. This says the word below. That means I need to be below X. So 0.09 is going to be below X. That lets me know how to draw my graph. So my graph's going to look like this. 0.09 is here. Now, they didn't ask me for my z-score, so I need to go back and look at what my mean was. Well, my mean was 3,350, so I need to go ahead and label my mean of 3,350. And I'm going to need that information here because we're going to do an inverse norm. And we're going to need our PMS. So we're going to need our percent, which is 0.09. We're going to need our mean of 3,350. We need our standard deviation of 773. So this is PMS for percent or probability, our mean, our standard deviation. And if you notice, we're shaded on the left side. So we need left. Now we can go plug that into the calculator. Second vars, inverse norm, area 0.09, mean 3350, standard deviation 773, coming from the left. And we end up with 231359. So $2,313.59. Lodging costs will be below that. Okay. Moving on to number 13. 64% of all lodging costs will be above. Once again, if I see a percent, I'm going inverse norm. And remember, take all percents and divide by 100. Now, this one you got to be careful with. It's a little trickier. So 64 divided by 100 is going to be my probability. So let's go ahead and knock this one out. It's going to have our same, much the same as we have just had before. So I'm going to go ahead and put my X. But now it says above. So that means it's up here. My 64 is above X. That means I'm going to be shading from the right. My mean is 3350, so that hasn't changed. But I'm shading from the right. Well, 50% is right here halfway, so I need to come over halfway because I need this area right here to be 0.64. So that's my area that I'm interested in, and we're coming from positive infinity. So inverse norm, area 0.64, mean 3,350, standard deviation is still the same at 773. Be careful. We know we have our PMS right. PMS. There's our probability. That's our mean. That's our standard deviation. But we came from the right, so we need to make sure that we have right. If you have positive infinity, you're coming from the right. So, second vars, inverse norm, area 0.64, mean 3350, 773. Change that left to a right. Oops, there it is. Make sure it's highlighted. Press enter, and we end up with $3,072. So our X that we were looking for is $3,072.91. All right, once again, if it's in blue, have to see it. Last problem. Draw a graph illustrating the empirical rule for the sampling distribution of the lodging cost average. No, that means I'm working with the X bar. You must show 3 standard deviations of the above and below the mean. You must clearly label the z-scores and the actual values and include the standard deviation. All right, so that's going to be a lot of work. So first off, let's go ahead and start with the z-scores because they're easy. All right. Remember, and if it's in red, you don't have to write it down. Z, the mean equals 0. The standard deviation is 1. That's the easy part. So let's start there. 0, 1, 2, 3, positive infinity, z-score. -1, -2, -3, z-score, and this goes to negative infinity. Plus or minus 1 is standard deviations for all normal curves, 68%. And we're centered about the mean. Plus or minus 2 standard deviations, 95%. Plus or minus 3 standard deviations, 99.7%. All right. So in our case, when we go back up the top and look, what was our actual? Well, our actual was 3,350. So our mean was 3,350, and our standard deviation of our actual was 773. But that's not what they want. They want the standard deviation of X bar. But we've already done the standard deviation of X bar. We did the standard deviation of X bar in part B. We used $64.64. I'm going to abbreviate that and just use $64. All right, your test will be a nice round number. So our standard deviation of X bar equals 64. All right, so I need the mean of my actual. My actual mean, or X bar, is 3,350. I'm changing by $64 each time, whether I'm going up or going down. Please remember, the empirical rule applies to the normal, but only to the normal, but it applies to all normals. So 3350 plus 64 is 3414, plus another 64, 3478, plus another 64, 3542. Taking the 3350 and taking 64 away, 3286. Take another 64 away, 3222 is 3158. All right, please remember, if it's in red, you didn't have to write it, but everything in blue is required. Good luck, study for your test, and thanks for watching. See you on the next one.